Today's session is a motor adapter set using myRIO. So, alright, let's take a look at this demo LabVIEW project for the motor adapter. For NI myRIO, I have the adapter plugged into MXP and the digital encoder motor is attached. Here is, and I am using a 9-volt battery connected, and here you can use any DC supply between 6 volts and 16 volts. And the VI is already running here. This is a VI already shown there, and the counter value can be changed. The counter direction is counted down. Is it running is anti-direction only? And if we can change the count, first we stop the motor and change the direction counting up, so it can be run is a clockwise, and the motor speed and the direction, the encoder feedback is registered here. You see the counter value as well as the counter direction indicator, and you can also reset the counter value. And with this control here, I am also displaying the feedback from the motor that shows the waveform from the motor, that the motor current and the motor voltage. Well, let's try starting the motor up now, and we will see a little action on the waveform display. The motor is not yet turning well, so first we can run the motor, and you can see the counter value here just changing. So by changing the frequency, the PWM frequency, the counter value can be changed, and it can be direction is counting down, and you can experiment with different pulse width modulated frequency, and you can observe the changes both current and voltage waveform. So increasing the PWM duty cycle, you can change the waveform frequency here generated, suppose 800. So this is the PWM signal, and here is a reset button is held down that counters reset on every loop pass, and presently the VI, that's every 100 milliseconds. In this way, counts can be used as a form of speed indicator. Right now you can change the PWM duty. Here you can change also the variation, the output waveform. And now moving to the moving to the block diagram window, show the samples. So the block diagram window, that's the encoder, PWM and digital output are present there. Shows the number of frequencies, number of samples that are necessary acquired the 5 PWM cycle, both current and voltage. And I will show the how the PWM frequency with modulated signal frequency automatically causes the number of samples acquired to reducing. So changing the frequency, samples will be changed. So let's take a look at first one, and that's the PWM express VI pulse with modulation. This is the VI PWM block diagram signal panel, and first we put the motor stop and then moving to the window block diagram panel, and you see a PWM VI. So double click on the PWM VI express, and you can see the configuration. The channel have connected there, A channel, A PWM0, pin number 27, set using input to express VI, duty cycle set using input to express VI. So there, and the encoder have present, channel A of A, E and C having there, and the digital output, the motor output shown here, that's the channel ADIO pin 11 have connected, and the motor adapter, that's we talk about the motor adapter here, that motor adapter having some features that connects directly to myRIO MXP and This is the MX3 pin and can control the following, that's 2 DC motor or 2 servo motor and 1 stepper motor also. So based on the edge bridge PWM motor driver it is, and motor current managed by TI TPS24 S711 model that over limit current protection, and it can be controlled PWM speed, direction control, encoder feedback, current and voltage waveform, 34 breakout pins connector and the MX3 pins, and the motor, that is the DC motor, it can be present here. It has the carbon brushes up to 12 volt DC can be supplied, and 2-channel encoder have been present, and this is the motor adapter, and also it is a myRIO mechatronics kit as a digital geared motor connected there, and myRIO having also present there. So the analog input shows the waveform chart, and the digital output coming the motor output current. First we can generate the PWM signal from the myRIO, and then it can be encoded and outputted by the motor. So this is our motor adapter setup using myRIO. So this is our motor adapter board. This one is the motor adapter board. It's connected with myRIO MX3 pin, and this is his DC motor. And the motor adapter set, it is a NI mechatronics set that can control the PWM signals, motor speed, current, and break down the over limit current. And this is our DC motor. It's can operate the 12 volt, 9 to 12 volt, and this is a DC power supply, and this is our myRIO. And now we can run the motor. So it is a direction clockwise now, and the motor adapter and the myRIO first generate the PWM signals that the motor adapter set can absorb, and the output is digitally that visualized in the motor. So that's our demo. Thank you.